On the night of the 19th of October 2017, an astronomer working on a Hawaiian mountaintop identified a faint moving point of light on a survey image and realized within hours that it was the first object ever observed inside our solar system from outside it. For the next 3 weeks, telescopes across the world tracked it. They measured its brightness curve, attempted to determine its composition, and computed its trajectory in increasingly fine detail. What they found did not fit any object in the existing catalog. 9 years later, the data still does not fit any object in the existing catalog. This is the cold archive. Begin with the instrument. Pan-STARRS, the Panoramic Survey Telescope and Rapid Response System, is a 1.8-meter survey telescope on the summit of Haleakala on the island of Maui in Hawaii. It is operated by the University of Hawaii's Institute for Astronomy. It was built originally to scan the sky for near-Earth asteroids that might pose a collision risk to the planet. By the autumn of 2017, Pan-STARRS had been running for nearly a decade. Its software automatically flagged moving points of light each clear night for review by human astronomers. Robert Weryk was the astronomer on duty on the 19th of October. He noticed a faint point that was moving at an unusual speed across the field. He requested follow-up observations from other telescopes. The follow-up came in within hours. The orbit fit, computed from the staggered position measurements, was hyperbolic. The object was not bound to the sun. It had entered the solar system from outside it, was passing through, and would leave.
From Robert Weryk, in a 2017 interview, the orbit was clearly hyperbolic. We had never seen anything like it. There was a designation system waiting to be used, and now we needed it.
The International Astronomical Union, which catalogs and names all minor bodies in the solar system, gave the object the formal designation 1I 2017 U1. The 1I prefix was new. It meant the first confirmed interstellar object. The discovery team, working with native Hawaiian language consultants, chose a name, Oumuamua, Hawaiian for scout or first messenger from afar. The directional trace of the inbound trajectory pointed broadly toward the constellation Lyra. The observation window was narrow. From the 19th of October to roughly the middle of November, the object was bright enough to track with high precision. After that, it faded below detection threshold. 3 weeks. That was the window astronomers had to characterize the first known interstellar object. In that window, 3 anomalies emerged from the data. Each one individually was strange. Together, they were unprecedented. Anomaly 1, extreme elongation. The brightness of the object varied with time in a pattern consistent with a tumbling body whose long axis was several times its short axis. Karen Meach and her colleagues, in a Nature paper published in November 2017, estimated the axis ratio at 6:1, possibly 10:1.
From Karen Meach, 2017. We had to consider the possibility that the body's shape is unlike anything in our local catalog. The light curve simply does not look like a typical asteroid or comet.
No comet and no asteroid in the solar system's known minor body catalog has been observed with that elongation. The previous record for a known minor body was about 3:1. Oumuamua was at least twice that, possibly more than 3 times. Anomaly 2, non-gravitational acceleration. Marco Micheli and colleagues, in a Nature paper published in June 2018, documented a small but statistically robust acceleration along the outbound trajectory that could not be explained by the gravity of the sun and the planets alone. Comets show this kind of acceleration. They show it because they are losing material, outgassing, which acts like a small rocket engine. The acceleration on Oumuamua was about 0.1% of the gravitational acceleration from the sun. Anomaly 3, no observed coma. None of the observatories that imaged Oumuamua detected the spectroscopic or optical signature of an outgassing coma. No tail, no dust, no gas at any wavelength examined at any time during the observation window.
From the 2019 Nature Astronomy Review by the Oumuamua International Space Science Institute team, a small, highly elongated body undergoing non-gravitational acceleration without visible outgassing is not a class of object present in our existing catalogue of minor bodies.
3 serious hypotheses have attempted to account for the combination. Each one accommodates 2 of the 3 anomalies. Each one strains the third. Hypothesis 1, a hydrogen iceberg. Daryl Seligman and Gregory Laughlin, 2020, Astrophysical Journal Letters. Their proposal: Oumuamua's body was made primarily of molecular hydrogen ice. Hydrogen sublimating from the surface would produce non-gravitational acceleration. The sublimation would be invisible to optical and infrared telescopes because molecular hydrogen does not have strong emission lines in the bands that were observed. The geometry of sublimation could explain the elongation. The constraint that strains it: hydrogen ice is not known to form stably in the interstellar medium under most modeled conditions. The proposal requires formation in the cold interior of a dense interstellar cloud, followed by transport to the inner solar system without complete sublimation. Hypothesis 2, a fragment of nitrogen ice from a Pluto-like body. Alan Jackson and Stephen Desch, 2021, Journal of Geophysical Research. Planets. Their proposal: Oumuamua was a chunk knocked off the nitrogen ice surface of a Pluto-class object orbiting another star.
From Jackson and Desch, 2021. Nitrogen sublimation provides the acceleration. The weak optical signature of nitrogen ice is consistent with the absence of an observed coma. Fragment geometry from surface stripping accounts for the elongation.
The constraint that strains it: the calculated population of nitrogen-rich fragments transported to our solar system from other stellar systems is, on current models, thin. For Oumuamua to be one of these, the production rate of such fragments in our galactic neighborhood needs to be higher than current models predict. Hypothesis 3, Avi Loeb of Harvard University and Shmuel Bialy, 2018, Astrophysical Journal Letters. Their proposal: Oumuamua's non-gravitational acceleration is consistent with the radiation pressure from sunlight on a thin, lightweight, sheet-like body. Such a body, they argue, is difficult to account for as a natural minor body. An artificial body, specifically a solar sail or a fragment of one, is geometrically simpler. Loeb has published further on this in subsequent years. The constraint that breaks it: there is no independent evidence for artificial origin. There is no direct test of the artificial origin claim within the available data. The 2019 ISI team review concluded that natural hypotheses are sufficient to explain the observations.
From the same 2019 review, while natural explanations for the observed properties are challenging, they are not exhausted. The artificial origin hypothesis is not required by the available data.
The second confirmed interstellar object detected, 2I Borisov, was observed in 2019. It behaved like an ordinary comet: visible tail, standard spectroscopy, cometary outgassing in the expected gases at the expected rates. Borisov demonstrated that interstellar objects can look exactly like our local minor bodies. It also left Oumuamua's combination of anomalies looking singular. One known interstellar object, 3 known anomalies, no other example. The Vera Rubin Observatory in Chile began full survey operations in 2025. Its detection rate for interstellar objects is expected to be significantly higher than Pan-STARRS. If Oumuamua's combination of properties is a real physical class, Rubin will eventually find another. As of June 2026, it has not. The window stayed open for 3 weeks. The case stays open. Wednesday's case. In Turin, Italy, in the early 1960s, 2 brothers built a radio receiver in their grandmother's attic. They claimed to have heard Soviet cosmonauts dying in orbit before Gagarin. The recordings still exist. So does the original equipment. The Lost Cosmonauts, Wednesday, 8 p.m. Eastern. See you then.